Okay, we want to find the values of C that satisfy the mean value theorem on this closed interval from 1 to 4. Our function is actually going to be 6x minus x squared. Now, because this is a polynomial, our function is going to be continuous everywhere and differentiable everywhere. So that means it will satisfy our conditions. In order to use the mean value theorem, we must be continuous on the closed interval, and we must be differentiable on the open interval. And because our function is a polynomial, we are continuous and differentiable everywhere. So we're definitely going to be continuous and differentiable on these small intervals here. You can see it's already factored, so you can see it goes through 0 and 6. The interval that we're looking at is from 1 to 4. So that would give you the 2 points, 1, 5, and 4, 8. Now you can actually count the slope, go up 3 and right 3. So your slope is 1. Or you can use these 2 points in the slope formula to calculate the slope. You end up with 3 over 3, which is 1. So the value of the secant slope is 1. Remember, our function is 6x minus x squared. So if you do the derivative, you get negative 2x plus 6. And we want to set our secant slope equal to our tangent slope so we can find the value of C that satisfies the mean value theorem on this closed interval. Okay, now let's solve this equation. We're going to subtract 6 from both sides. And then we're going to divide both sides by negative 2. Final answer, x equals 5 halves. So 5 halves is the spot where the slope of the secant line and the slope of the tangent line are both equal to 1. Okay, this is the exact same example, same exact function. It's just a different interval. Instead of going from 1 to 4, we're going from 1 to 5. Now you can probably see that they both have the same height. Beginning height is 5, the ending height is 5. So that gives you a line with a slope of 0. And when the slope is 0, we don't really call it mean value theorem. We usually have a special name for it. We call it Rolle's theorem. Now you can check that the secant slope is 0. Plug in the 2 points, you get a slope of 0. And what we're looking for is we want to know where is our tangent slope equal to 0. So we want to solve this equation, see what we get. We're going to subtract 6 from both sides. And then we'll divide both sides by negative 2. We get x equals 3 as our final answer. So 3 is the spot where the slope of our secant line and slope of our tangent line are both equal to 0. And instead of calling this the mean value theorem, we have a special name for it. It's called Rolle's theorem. And that's because it usually means that there's going to be a max or a min. In this case, we get a max. So the value of C that satisfies Rolle's theorem is going to be 3. A C value of 3. Okay, the first 2 examples were the same function. They were just a polynomial. So polynomials are continuous everywhere and differentiable everywhere. That was pretty easy, but this one actually has an issue at x equals 3. You know how to graph a rational function, you'll know that this is a vertical asymptote at x equals 3. You can look at the picture, and that creates a problem because that means our function is not going to be continuous at x equals 3. Now, if our function is not continuous at x equals 3, that doesn't mean that you can't use the mean value theorem. It's possible that 3 is not in your interval, so we want to check, is 3 inside of our interval? In this case, the answer is yes. There's a discontinuity at x equals 3. It's called an essential discontinuity. And that's because at least one of the one-sided limits does not exist. That's why we call it essential discontinuity. But if there's a discontinuity inside of our closed interval, then we cannot use the mean value theorem. Now, what if our interval is different? Instead of going from 1 to 5, let's go to the next one. This one goes from 5 to 9, but it's the same exact function. So there's still a vertical asymptote at x equals 3, but x equals 3 does not land inside of our interval. So for this one, it's okay. So even though there's a problem at x equals 3, if 3 does not land inside your interval, then you're okay. You can still use the mean value theorem. Of course, if x equals 3 does land inside your interval, you would just stop, and you would not be able to find a value of c that would satisfy mean value theorem on that closed interval. Okay, now that we're dealing with an interval that we can use the mean value theorem, we're going to go ahead and do it. Again, you always want to satisfy the conditions for the mean value theorem. So let's do that first. So in order to use the mean value theorem on the interval from 5 to 9, we have to satisfy the conditions. And so we're going to say that y is continuous and differentiable everywhere except at x equals 3. So if x equals 3 is the only problem, and x equals 3 does not land inside our interval, we can now conclude that y is continuous on the closed interval from 5 to 9 and differentiable on the open interval from 5 to 9. So this is what I would write to satisfy my conditions for the mean value theorem on the closed interval from 5 to 9. Now we can find the value of c that satisfies the mean value theorem on the interval from 5 to 9. Remember, the mean value theorem just guarantees that there's at least one spot inside that interval where the slope of the tangent line is equal to the slope of the secant line. So it's just guaranteeing that there exists at least one spot. And we're going to go find that spot right now. So in order to find that spot, we're going to have to find the slope of our secant line. You plug your 2 points into the slope formula, and you get -1/2. So that's the slope of your secant line. It's -1/2. To get the slope of the tangent line, you have to do the derivative, and that's going to be the quotient rule. This is what you would get. And now we want to set those two things equal to each other and solve. Now, if you solve this without a calculator, you would get 6 plus or minus square root of 48 over 2. That's the same thing as 3 plus or minus the square root of 12. Now, we are getting two answers, but we can only use the answers that land inside of our interval. So which answers land inside of our interval? Well, only the one that is 3 plus the square root of 12. That's this point right here. 3 minus the square root of 12 is over here. The slope of the tangent line is equal to the slope of the secant line over there, but it's not inside of our interval from 5 to 9. So we're going to have to throw that one away. So the only c value that works is going to be 3 plus the square root of 12. The decimal approximation would be 6.464. That's the value of c that satisfies the mean value theorem on our closed interval from 5 to 9. So what I'm trying to point out in this example is that even though our function was not continuous at x equals 3, you can still use the mean value theorem from 5 to 9. Because from 5 to 9, our function is continuous and differentiable. So for this example, we had an issue of continuity when x was equal to 3, but that didn't matter because our interval did not contain 3. So we could use the mean value theorem on this closed interval.